Hello, we're your hosts Fatima Patino.
And Bong Fam.
And welcome to this week's edition of Science Saturday. So I was at the dentist the other day, just dreading to hear the results from the dentist, and I was pleasantly surprised to see that I didn't have any cavities.
Haha, do you not brush your teeth or anything?
Of course I do, let's get this straight. I'm extremely hygienic, but it's a struggle for me not to get cavities.
Bet.
Honestly, but anyways, naturally I wanted to know how the sorcery had been done. The dentist gave me some interesting news.
What's that?
The county has actually decided to put sodium fluoride in tap water.
Isn't that already in toothpaste?
Yeah, but just imagine, you're low-key brushing your teeth every time you drink water.
That's actually pretty neat, but is it safe?
After my visit to the dentist, I was so intrigued by sodium fluoride that I decided to do a bit more research. Let's analyze this compound from its atomic and elemental properties to modern-day use.
Yeah, I think that'll definitely help the public understand it better.
It's pretty obvious to tell what sodium fluoride is made of.
Bet. Is it carbon and krypton?
I hope you're kidding.
Yeah, I was.
If you thought sodium and fluorine, then you have basic common sense. Sodium is a part of the alkali metals family, while fluorine is a part of the halogens.
For any of you who might have completely zoned out in chem class, here's a quick description of where these elements are on the periodic table. In Sam Keene's book, The Disappearing Spoon, he compares the periodic table to a castle with taller towers on each side. The column to the very left of the table is alkali metals. They have only one valence electron.
Hey Bong, I was asking my friend if he had any good jokes about sodium, and you know what he said?
What?
Nah.
Oh wow, that was something.
Okay, don't act like you didn't like it. But moving on, the column second to last on the right side are the halogens. They have 7 valence electrons. Elements from these two families are very reactive, especially with members of the opposite family.
Hey Fatima, why is that so?
Atoms of elements try to complete something called the octet rule. It basically means that atoms want to have 8 valence electrons in its outer shell.
So, to have the last shell filled in the right. Now, you don't have to be a math expert to know exactly what 7 plus 1 is, 8. So, an alkali metal can give its 1 valence electron to a halogen and give a halogen a complete outer shell, as well as take away the extra outlier in the alkali metal's electrons.
Both of these elements would be happy since their outer shells are complete. You could say elements in these families were just made to fall in love and complete each other.
The halogens are nonmetals with some qualities like being brittle solids or gases, dull, no luster, low melting and boiling points, poor conductors, gain valence electrons.
Alkali metals are...
Oh, let me guess. Metals.
Wow, what a psychic. But yes, metals' characteristics are exact opposites of the halogen families. High boiling and melting points, high densities, good conductors of heat and electricity, they're hard and shiny, malleable, ductile, and they lose electrons.
What's important to note here is that elements in a family have similar properties because they all have the same number of valence electrons. This characteristic was very important in the development of the periodic table because scientists searching for these missing elements in the table knew what attributes to look for.
Yeah, so for example, the element beneath fluorine, chlorine, would also have 7 valence electrons in its outer shell, and it's a gas. Scientists could actually predict and confirm that that element existed. And this wouldn't be a full overview if we didn't mention the trends that characterize fluorine and sodium even further.
Electronegativity is the ability to pull electrons away from another atom. It decreases as it goes down the table and increases as it goes to the right. Elements towards top of the periodic table have less shells, so the protons are more exposed and can attract electrons better. As a matter of fact, fluorine is the element with the highest electronegativity.
Ionization energy is the energy an atom has to put in to pull electrons away from another atom, and it actually goes alongside electronegativity. It decreases as you go down, but it increases as you go right. Miss Kennedy, a chemistry teacher at Peachtree Ridge High School, came up with a clever analogy for this. So think Halloween candy. If you have candy that you don't like, it won't take as much effort for someone to convince you to give them your candy. However, if you only have a little bit of your favorite candy, it would take a lot more for someone to take it from you.
Honestly, just eat all the candy. I mean, we have sodium fluoride in water. It's gonna be okay.
True.
Atomic radius increases as it goes down and decreases as it goes to the right, so the atomic radius of sodium is larger.
Reactivity increases as it goes down for metals, but it decreases as it goes down for nonmetals. And this is impacted by its ionization energy and electronegativity. When elements from our families make compounds, they are formed through ionic bonds.
Those are simply bonds between metals and nonmetals, as stated in Britannica. Alkali metals react vigorously with halogens to produce salts, the most industrially important of which are NaCl and KCl, according to the Yale Encyclopedia of Science.
In the case of fluorine and sodium, it creates sodium fluoride. Again, very creative naming, right? It's a colorless crystalline solid or white powder and is soluble in water. Chemical properties include that it is non-combustible and it is corrosive to aluminum.
As we have mentioned before, sodium fluoride is used as a compound to prevent tooth decay.
The University of Nottingham produces these periodic table videos, and call me a nerd if you want, but they are very interesting.
Nerd!
Hey, I learned that the enamel on your teeth is made up of a compound of calcium called apatite.
Hold up, something in your mouth is called apatite?
Yes, haha. I wonder if that's why we're craving food all the time.
Wait, really?
No, your enamel has no relation to having an actual food appetite. Let's get that straight. But anyways, the apatite dissolves pretty easily in acids, which most of our foods have.
Like the Halloween candy we were talking about before.
Halloween. Yep. Yeah, so when you brush your teeth with that sodium fluoride, some fluoride bonds with that apatite and makes fluoroapatite that is much more resistant to dissolving.
With that evidence, I'd support fluoride in my water.
Yeah, you'd think that's pretty convincing, but since the 1940s, when fluoride was first introduced to water, there has actually been an ongoing debate whether it's safe or not. We read an article about it from the Washington Post that did an excellent job of breaking it down.
Water fluoridation is endorsed by the American Medical Association, the American Dental Association, and the CDC. It's not hard to see why. If you were a salesman for fluoride, you would have walked away with a good amount of money right now. I'm sold that fluoride in our water is a positive thing.
You'd think so, but the opposing side believes that fluoridation is an unethical form of mass medication without each individual's consent or knowledge.
That's some next level government conspiracy right there.
By putting fluoride in drinking water, the dosage can't be controlled since some people drink much more water than others.
This is a tough one, guys. Sodium and fluoride are some simple parts of the periodic table, yet their atomic structure, qualities, and bonds have made them something pretty important that, believe it or not, you deal with every day.
So what's your opinion, guys? Share your thoughts with us in the comments.
Now get ready to sink your teeth into this great joke.
Oh no.
Now you need to brace yourself. It's
why?
hilarious. So you won't be looking down in the mouth after hearing it. What do you call two dentists that live on the two opposite sides of the world?
What?
Molar opposites.
Oh my.
Yeah.
My dentist would kick me out of his office if I said that.
What? Come on, that was pretty good.
Okay, 3 out of 5 stars. But thank you guys for joining us this week on Science Saturday. We hope to see you back.
Bye.
Bye.